Hey everybody, welcome back to the Open Source Office. I'm joined once again with Vinay and the team over at Konma.org. Right now, they're going to go ahead and give us a demo of the HaskLedger project. And Vinay, I'll hand this off to you.
Thank you, Tex. So yeah, guys, I'm Vinay. I'm founder and head of research and development at Konma. So I went to Emergo for my education. That is how I got to know about Cardano. And we are a Fund 7 funded project. So we got funded for developing talent pool here in India in Fund 7. So it started there. So the journey started there. And Fund 8, we got funded for hosting ideathons here in India. So out of which we had 50 projects taking part, and out of which 21 projects is what we've selected. And we started working on them. And now from 2021, beginning of 2021 till date, I would say like it's a long journey and a lot of projects that we've been involved in and working closely with Cardano. So today I would want to a presentation, a technical presentation on HaskLedger, which is a Fund 11 funded project, which is an open source project that we are working on, which involves open source hardware rather. So till now the topic is about open source software with blockchains and a lot of things. Now our I would say the concern is about bringing in open source hardware or systems on chip is what we are trying to do, or bringing scalability and security on a hardware level. Yeah. So I'll just present HaskLedger. Yeah. So yeah, guys, HaskLedger Fund 11 funded project, and great progress into how we've been building this particular project. And now we currently have two Indian universities joining us to take this whole initiative forward. So HaskLedger is an open source project for basically edge computing or edge cases is what we say. So we are concentrating more on open source hardware. So we are using RISC-V, a RISC-V SoC, a RISC-V SoC again, meaning systems on chip, meaning domain specific chips is what we want to create and run a Cardano on. It's more of like running Cardano on a systems on chip. Yeah. So why are we doing this? I would say this is like the what you see on the screen is the architecture. It is it's more a very modular architecture that we have designed for HaskLedger. Now, what you see on the screen, starting from RISC-V to the UI UX layer, the QBase OS. So now RISC-V and NUTX OS. So bringing computation or edge computing is what we are aiming at, bringing computation to a very it's more like a hardware level computation and security that's happening here. So the foundation layer consists of RISC-V and NUTX OS, which is a real-time operating system. So on top of this RISC-V and NUTX OS is where we have the execution layer, unikernel, VM in Haskell, the Rust libraries. So this is the execution layer where we concentrate, or it's more of like safe concurrent computation that happens here. Now with unikernels, it's thin client computing, isolated, and we are reducing the attack surface, so making it much more safer. And with Haskell VM, again, Haskell is known for its type safety and concurrency and a lot of, so the pros that Haskell has got, which helps us get the whole virtualization. It's more of like correct, we add correctness to this entire system. And with Rust, the memory safety comes with Rust. And on top of that, it is the consensus and the interoperability layer. So this is where we would want to run the Cardano node. Yeah. So now coming to the decentralized and the zero trust architecture, we are aiming with Haskell on the whole. The things to be noted here is one, the RISC-V, the open source hardware, and the thin client computing that comes with unikernels, which helps in reducing the attack surface and makes it self-contained. Now with uh, Haskell comes formal verification and symbolic execution. So basically, this ensures predictability, deterministic execution, and trustworthy behavior of the entire system. Meaning, it can be mathematically proven. So now with Haskell, the Rust for memory safety, and then we have Haskell modules, or basically the smart contracts that run on top of these, uh, which would add security, safety. So it's more like it's a modular system where the security and scalability is on the bottom layer by default, and then with formal verification and the rest of it adding security on the execution layer. And now it's about like, why are we building this? uh, for example, a use case that we work with is with a government project where uh, we are measuring the quality of air and quality of water real time. Now this is a lot of data that is coming into the system. Now we know that all the content or all the data cannot be put on chain. So what we are aiming here is uh, a RISC-V SoC or an IoT connected to this particular hardware that takes in data. And now we have AI/ML algorithms running on this SoC. When these AI/ML algorithms detect an anomaly in the system, they put it on chain. It's not the entire data of the air quality and the water quality that is going on chain. It is when there is an anomaly that is detected, meaning like something is wrong with the system, or if the goal is achieved. So we want to know basically when the goal is achieved and when there is something wrong with the system. So that is why we've taken this particular approach where open source hardware or systems on chip on a foundational level, and with the rest of it in the execution layer with the right, I would say, like approach when it comes to formal verification. So the security is there throughout the system, meaning security is embedded throughout the system. So this is an architecture. So where we are running on the exterior end, what you see here is where the Cardano node is running, where anything that we would want to like put on chain can be achieved near instant with the hardware side of things, and then you can put it on chain. So this is how we are leveraging HaskLedger, basically a side chain that comes with an open source scalability, meaning open source hardware with scalability and security. Yep, this is, I would say, like an intro to the project, and we have a detailed design document that we have designed for this, and it is all open source. So what we feel is we have done our part from our end on behalf of Konma building HaskLedger, and now we think it's high time we put it forward for the wider Cardano community to like participate. So the motto behind what we are, what I'm doing right now, pitching this, is to like, uh, this has been built in stealth so far, but now it is about putting forward to the community, and we would want the community to like take this whole initiative forward.
Wonderful. Thanks so much for sharing there, Vinay. And we'll make sure that your information here is tagged for anyone who wants to get maybe, let's say, more involved or find some other utility here on the project.
Thank you.
All right.